Hey guys, this is Jeffrey. I'm here to do a quick video on recursion in Java. So in Java, and in any programming language really, recursion is simply when a method is calling itself. It typically does this to break down one complex task into a series of smaller tasks which can be resolved independently. And then by combining the results of those tasks, it can come up with an answer. So as a brief introduction to recursion, actually Google's got the best way of showing you. You type in recursion to Google, it'll say, do you mean recursion? And you keep clicking recursion and it keeps pulling up the same page. That's kind of the way recursion works, is that you're always going to be calling the same method and running a similar algorithm. Of course, in Java you'll get different results eventually and reach what's called a base case, which is a case where it can actually stop recurring. In this case, you get an infinite recursion. That's not good, but it's very funny, and I felt like I should show you that. Anyway, in Java, recursion, as I said before, is a way of breaking down a relatively complex task into simpler tasks. So one example that I've seen used before, it's a good example for explaining it, is factorials. Now, the thing to be cautious with a lot of recursion examples is that the simplest ones typically aren't very practical. In a lot of cases, it is not as efficient, not nearly as efficient, to use recursion when you could use an iterative algorithm like a for loop or a while loop. However, to illustrate the purposes of recursion and for the purposes of studying for the AP test, this is the kind of stuff you'll be expected to know. In real-world applications, you'll find that you very, very rarely will need to write recursive methods. And if you do, it'll be relatively clear because it'll be a case where it's actually easier to use recursion. For the purposes of AP computer science, oftentimes it's harder to use recursion, and you just have to do it because the AP test wants to see that you can manage that. So, big thing here is I'm going to start going over this first method right here, this factorial function. You notice, so it's being passed a number, and it's going to return the factorial of that number. Just to make sure everyone, just to put everyone on the same page here, factorial, I'm sure you all know this, such as 5 factorial is equal to 5 times 4 times 3 times 2 times 1. It's the sum, you could say, of all numbers, all integer numbers equal to and below that one number. So in this case, when I'm passing 5 to this function, the operative code here essentially is return number times factorial of that number minus 1. When you call factorial on number 0 or on 1, the answer is always 1. So this right here is called the base case. It is the case that recursion always tends to move towards, and if you don't move towards a base case, you'll get infinite recursion. If I took this out right here, this function would call itself infinitely, and the result would be a Stack Overflow exception. You don't want those, definitely. But so you always have to have a base case. What happens here is, since you're being passed a positive integer and you're subtracting from it, you will always hit 1 or something below 1, because if you're past 1, it would subtract and go to 0. And in that case, it will simply return that value of 1. At that point, it'll be able to go back to this line of code here, this return num times factorial num minus 1, and for the number that came before it, for in this case it would be 2, it'll say, okay, 2 times factorial 1. Well, it knows factorial 1 is 1, so it says 2 times 1. So that function then is going to return that value of 2. The function before that called this function, is 3 times factorial of 3 minus 1. Well, the factorial of 3 minus 1, factorial of 2, we've already figured out is 2. So now it's going to say 3 times 6, or it returns a value of 6, and so on. That's the way recursion works, is essentially you're building a stack of method calls. What happens is the first method, the first call here, such as return num times factorial num minus 1, goes on the bottom of a stack. The easiest way to envision this is to have a bucket, and imagine writing down the command and putting it inside that bucket. That's where it is in the stack. And then for each subsequent command, you put it on top of that. And note that at the end, when you've got that 1 on the top of the stack, in order for any function below it to be completed, that function on top must be completed. That's the base case. You can't finish recursion without that base case. So what happens is, once that function is resolved and returns data, the function below it on the stack can function and return data. And then the one below it can finish, return data all the way down till you get to the bottom of the stack. And the first function call, the one you really care about, the one that you'll see right here, the original one, is going to return a value that can then be used. So to kind of illustrate that concept, I've got this second function here called stacks. And I called it that, 1, because I couldn't call it fact again, and 2, because it's really illustrating the idea of a stack. When I run this code, you'll see this first print line right here prints out a value of 120, 5 factorial. That's just showing you that it's working. The second one here is illustrating that idea of a stack. You notice that the first thing it prints out is 5, because that's the first thing you call it with. Then it's printing out 4, then 3, then 2, then 1. But you can, and the way you see it right here is what you see, this 1, is the result of the last call to this method. It would be the first one on the stack. So if you went in backwards order right here, 1 times 2 times 3 times 4 times 5, that's the way it's being done in computer memory. So if I were to, depending on where I place this print statement, the order in which these are printed out actually changes. Because remember, I put this print statement at the top. That means that this print statement is executed before any of the rest of the code in this function is executed. If I move that print statement to another point in the function, the order of this could actually change. For instance, you'll see, move that print statement here, run it again, and it's only running once because that's the base case, which is to be expected. The base case typically in recursion is only called once. If I move that down here, it's being called in all cases but that base case time. So, and that's sort of how that's really how it's going to go for recursion, is that based on where you put a print statement, it's going to change how it runs. But the really big thing to know is just know the order in which it is occurring. Know that the last method call, in this case when you're calling to the base case, is the first call that actually finishes and returns a value. That means that the second to last call is actually the second one to be finished, and so on. So that's the big thing the AP test loves to do. They love to give you recursion with print statements in a bunch of confusing places and say, hey, what's going to be printed out in what order? And my suggestion is just on your paper, draw a bucket and write in stacks and what should be done on each stack. And you'll see as you write it in, if you write it in the order, the stack on the top is executed first, and you can just read the output right from that image you've created. It makes it a lot more easy to visualize it that way. And just one thing to be aware of, the way this is represented in actual memory in a computer is slightly different than actually having a stack like that. The function is exactly the same, but it's got a slightly more efficient way of holding it in memory. So the stack is a concept people use to think of it. However, the way it actually works is slightly more compact in the actual computer. Just because there's an easier way to represent it than actually having the computer build a complete stack. It can actually compress that memory a little bit, which is very important. That brings me to my last point, is that in recursion especially, memory is a huge problem. You need to make sure that you're not wasting memory, and that's why recursion is oftentimes inefficient. It tends to be a big memory suck. So just be careful when you're using it. Typically don't use it for math because you don't want to be using too much memory in your recursion. It tends to do so, but just be careful with it. And I'd say the big key about this is remember base case and remember the stack. If you know those, you've got recursion. And that's it. Thanks for watching.